Hello everyone. So in the last lesson, we talked about the big picture of this chapter, okay? And in the next two videos, we are going to conclude this chapter by including some working examples. These examples represent the question that you may be asked during the real exam, okay? So if you're watching this video, I encourage you to think first, do it first, before proceeding watching the solutions. Okay, so let's get started. The first question, this is intended to be an easy question. Okay, so suppose that x and y are random variables. The marginal PDF of x is this one, and conditional PDF of y given x is this one. So this one is the marginal, right? So the keyword is the marginal. And this one is a conditional of y given x. There are two sub-questions. First, determine the marginal PDF of y. And second, determine the conditional PDF of x given y. So think first, okay? So let's pause this video and then we'll come back. Okay, come back. So I assume that you have been doing this already, okay? And this one is intended to be easy. But if you are not sure whether you get the right solution, it's okay, because you can watch the last clip, which is about the big picture, okay? And this question will be very easy. So the solution is this one. We are going to find by starting, because we have f and g, right? If we multiply them together, what do we get? We get the joint. H stands for the joint PDF, okay? The joint PDF is gonna be this one, within this boundary, okay? And how to get from the joint to the marginal? We use the process of flatten out. Because this one is a continuous distribution, the process of flattening out is to get the integration, okay? The integration, and we have to take care about the boundary too, because x starts from y up until 1, okay? X starts from y up until 1, this one, and we get this one, okay? Within this boundary, otherwise dy is equal to 0. And then if you are going to find f of x given y, because we have what? We have the conditional in the reverse direction. So here, we are going to use the Base Theorem, okay? The Base Theorem. And after multiplication, we get this answer within the same boundary as the first one, okay? So clear? So this one is intended to be easy, okay? So how to answer this? The first component that we have to answer is the answer, the main answer, okay? These two are the main answer. And do not forget to answer the boundary too. I've seen some students didn't answer with this one, and they get only half of the full credit, even though they did everything correctly. Because without this one, this is not the PDF at all, okay? So you have to include the boundary too. And same as this one, we have this one, okay? We have this one, and this one is the main answer. But we have to include this boundary too. Okay. Let's go to the second question. Okay. So this one is a little bit more tricky, but it's not that hard, okay? Suppose that x and y are independent random variables with the following PDF, okay? f1 of x, f2 of y, okay? So this one is the PDF, okay? And they're independent. So determine the value of probability that x is greater than y. Okay. So pause the video, take your time, okay? And if you finish doing this problem, so you can continue with this video. Okay, come back. So I assume that you have done this already. Okay. So the process of this one, remember the keyword. The reason that in the last lesson I talk about the big picture, because in this video and in the next video, when we are doing the problem set, okay, I am going to refer to the last video when we talk about the big picture. So let's look at this one. This one is a PDF, okay. We have the PDF of X and we have the PDF of Y. However, with these two, can we get the PDF? That's the basic question before finding the answer. Can we get the PDF? The answer is no, except one special case. One special case is that X and Y must be independent random variable, and we say yes. And that is the first concept that this question tests upon, okay? So in the exam, it's not just about testing only one concept. It is testing a few concepts or many concepts, but you have to merge them together, okay? That's why I talked about the big picture last time. So first, we have to find the PDF. With the PDF, we can find everything, right? With the PDF, we can find everything. So let's get started. In this one, okay, in this one. Because X and Y independent, we can find fxy is gonna be this one. X between 0 and 1 and Y between 0 and 0.5 and 0 otherwise. X greater than 1y is gonna be this one, 0, 0.5, 1, y, because X is between, let's say, the Y and 1, okay, and the Y and 1. So let's consider this carefully, because let's say this one and this one, right? So if X is greater than Y, that means what? That means we are considering only the case, okay? Only the case that X is between Y and 1. Okay, X is between Y and 1. Here. X is between Y and 1. Because, can we test 0.5? The answer is no, okay? Because X must be between, let's say, 1 and 1, okay? And Y, we take this condition instead. So the order of integration, okay? This question tested another thing, another trick, which is that how do we come up with this order? So the first thing that we see this question is to draw a graph, okay? It's to draw a graph. So this one is X, okay? This one is Y. We're going to draw the support. X between 0 and 1, and Y between 0 and 0.5. The support is going to be like this, okay? It's going to be like this. However, what we are interested in is what? Is X greater than Y. So how do we find? X is greater than Y. It's gonna be something like this. It's gonna be only this area. That is, it is as if we do not have this area. So the first direction of the integration, okay, because we integrate the X first, right? We have to find where X lies on. So X lies between what? Between Y. Oh, okay. I see. It's not this area, but the opposite one. Okay. Sorry about that. The opposite one. Because X is greater than Y, right? So it's gonna be this one. This area is correct, okay? This area is correct. So X is between Y and 1 if we are taking in this direction, right? And Y is we take this area. throughout this direction from 0 to 0.5. That's how we come up with this order of integration. However, if we switch the order of integration, what happens? Okay, somehow that, okay, you want to integrate dy first. Can we do that? Yes, but it's a little bit trickier, okay? It's a little bit trickier. So the question is that we have integration like this, okay? xy, dx, dy. So what should be the boundary? What should be the boundary? Looking at this picture. Okay, look at this picture. So first, if you, okay, dy by dx, right? Because this one is the same. Dy by dx. How? What order should we find? Okay. So first, we have to find the order of y first. However, there are some problems here. What are the problems? The problems are that when x between 0 and 0.5, y extends, okay? Y extends between 0 and x, right? Y extends between 0 and x up until x equal to 0.5. But after that, it is going to be 0 and 1. And the x is simple because the outer integration. So in this situation, I suggest you guys to split the area, okay? This is the simple technique from the calculus, okay? Split into this area. So the boundary of integration is gonna be y, okay? Y between 0 and x. For x from 0 to 0.5. And we plus the other area, okay? We plus the other area. So y is between what? Y is between 0 and 1, right? And x is between what? 0.5 and 1. Because these two numbers are not exactly the same, are different, unlike if we have in this direction. We can check that the answer is the same. Okay? So in the question like this, another trick is that you have to find the order that is easiest to integrate. But it's not mandatory, okay? If you happen to integrate dy first, that's okay. But you have to remember the simple tricks from the calculus, okay? So the calculus that if you have some strange area like this, one thing that you have to do first is to split the area to be easier for integration. Okay? So the answer is 2/3. Okay. So that is the end of the first part. Okay, I tend to keep it short because I have four questions in total. And in the next video, we are going to look into the third and the fourth question. Okay, see ya.